My dear friends, welcome to Rajashekar classes on Applied Data Science with Python. This is lecture number 412. In this lecture, we will try to understand bias variance trade-off. We have seen random forest or bagging in general is a great way to reduce variance. Random forest tends to have a very low bias because your base learners are base models. What are the base models? I can say base models are MIs. Base model MI. MI means what? M1, M2, so on, MK. These are base models. Because of your base models are low, these base models are low biased models. So what is your final model? Our final model, capital M, is nothing but it is an aggregation of your base models M1, M2, M3, so on, MK. So as K increases, your variance would decrease, which means you are going to overfit less and less. As K decreases, we are going to have increase in variance. As far as bias is concerned, bias of the total model is equal to bias is the bias of the total model is same as the bias of the individual models. You will not surprised to see I have seen cases where people trained 2000 base learners, 2000 decision trees and then aggregate them, because more is the better. And at the same time, there is one more interesting hyperparameter, which is first. So if my data set is Dn, let me say Dn is my data set. I am saying I will do row sampling and column sampling to create a data set D1 such that you have D dash here. Just see what is D? D is number of features in my original data set, isn't it? N is number of rows, number of points, isn't it? What does it mean? This D dash, your D dash here, you have D here D columns, here you have D dash columns, here you have N points, here you have M points. Your D dash must be less than D and your M must be less than N. Let's see the sampling ratio. Sampling ratio is nothing but D dash by D. This is your column sampling ratio. D dash by D is column sampling ratio. Similarly, M by N, this is your row sampling ratio. We have two ratios. One is column sampling ratio and another one is row sampling ratio. Basically, it says what percentage of points you are sampling. If you say only 20% of points for row sampling, or if you say if you keep 50% of points for column sampling of columns, let it of column sampling for keep 50% of columns here to train a model. If these percentages go down, if your column sampling rate and your row sampling rate, if these two things are low, what happens? If your column sampling rate and row sampling rate are small, each of data sets D1, D2, D3, so on, they are more different. If they are more different, then what do you have? You have low variance model, isn't it? Or in other words, your variance reduces. But of course, you should not keep your row sampling rate so small. For example, if you say row sampling equals 0.1%, then you may not have points in D1 to train a model. So keep them to reasonable level and play around with them. But the general rule here is as column sampling rate and row sampling rate reduces, variance also reduces. That's the general rule, isn't it? But oftentimes what people do is people fix these values. Which values? People fix these values, RS, row sampling and column sampling. They fix this. What they fix RS and CS, row sampling and column sampling. Let me keep increase number of models. Let me say M1, M2, M3, so on, MK. And of course, you always keep on keep one data set away. You must always keep one data set, keep one data set away, isn't it? Yes. How do you actually train the model? You have your DN. I have my DN, isn't it? Which is your training data. What is this? This is basically training data. Yes, that's what it says. This is your DN is your training data from which you are creating D1, D2, so on, isn't it? And training your models M1, M2, so on. You have your D test, isn't it? D test which is not, this is not touched. D test which is not touched, isn't it? And you have DCV. DCV means what? You have trained all of your cross validation. DCV means what? You have D test. Let me repeat. You have D test. Just a minute. Yes. Okay. This is D test. This is DCV, isn't it? You have your D test which is not touched. Similarly, you have DCV. This is DCV. You train all of your models. You cross validate here. After training, what we need, you cross validate. After training, you have to cross validate here. Which cross validity? You will see what is the use of cross validity. Why do we need? You cross validate here. While cross validating, you will see what is the best K. What is the purpose of cross validation? To find best K. Yes, what is the purpose of cross validation? To find best K. So what you can do as far as cross validation here is concerned, you can say what happens as K increases. K is basically, what is my K? K is basically number of decision trees. K is basically number of decision trees, isn't it? Or number of base learners. Otherwise, I can say it is number of base learners. Base learners or number of decision trees. So what happens often is as K increases, let's assume as K increases, just say as K increases, let's assume this is your performance. Just let me say this is your performance. Here your K is number of base learners or x-axis, isn't it? This is your model. This model, what happens? On y-axis I am taking performance, on x-axis I am taking number of base model. Beyond this particular point, I am plotting a graph. Beyond this particular point, it's not increasing, isn't it? Beyond this point, it will not increase further. Now you can say this K equal to 200. When you can say yes, 200 base learners, 200 trees. What is 200? 200 base learners, 200 trees. I can say 200 decision trees. I can say, isn't it? Yes, 200 decision trees. Random forest is very good performance. Let's say 90%. Let me assume this is 0.9. Therefore, that is, I can say 90% accuracy, isn't it? Beyond this K equal to 200. Just see, beyond this K equal to 200, it is not improving model much. So you always had D cross validation. You do all of this training of multiple models on D train. You have to train models on, you have to train the models on what is this? This is D train. DN, isn't it? On D train, keep your D cross validation, keep your D cross validation and D test to understand number of base learners. This is D cross validation is number of base learners, to find number of base learners, isn't it? And you should have D test to report your model performance. To report, D test is used for report model performance. Model performance. Standard protocol. What is our standard protocol? Standard protocol is first train, then cross validate, which is useful for finding right K, and test. What is the use of test? Testing is to report your model performance, isn't it? Therefore, standard protocol is train, cross-validate and test. Cross-validation is used to find the hyperparameter k. The most important hyperparameter is the number of base learners. You can control it. You can increase or decrease. You can increase or decrease it. There is, of course, there is other hyperparameters here, which your row sampling rate and column sampling, row sampling rate RSR, column sampling rate CSR. Isn't it? Therefore, row sampling rate and column sampling rate, but people don't speak lot about it. They fix to some reasonable number. Of course, you have always option to change column sampling rate and row sampling rate. Then you have three hyperparameters. You have your k. K is one hyperparameter, which is number of base learners. What is your k? K is hyperparameter, which is number of base learners. Number of base learners, isn't it? And you have column sampling rate. This is one hyperparameter, and CSR and row sampling rate, row sampling RSR. You can do grid search to find the best hyperparameters. As far as bias variance trade-off concerned, we typically mostly play with the k, the number of base learners. We typically use decision trees that are fully grown. That is very important because they tend to have low bias and high variance. I request all of you to go through this particular lecture. If you have any difficulty, please keep a comment. Thank you very much.